I thought today we would talk about carburetor theory, and I made a couple of models. You're going to find that probably 90% of your problems with a small engine are related to your carburetor, not so much the internal parts of your engine. What we have here is a cylinder with a piston in it and a spark plug on top, and somehow we have to get the proper air-fuel mixture out of this bowl into this cylinder. How do we do that? Well, we do that with a carburetor. Now, we've made a couple of models here, and if you will, bear with me, this is a carburetor throat. Over here would be an air filter, if you will, allowing air outside of the engine through this tube into this cylinder. And the way that's achieved is with the piston coming down, it's creating a vacuum, sucking the air outside of the engine through this pipe and into that cylinder. Right here we have a fuel pickup, or an emulsion tube, if you will, that fits inside of our tube. And what we want to do is get this fuel mixed with this air into this cylinder. Okay? How do we do that? Well, they were very clever about this. They put a couple of obstructions inside this pipe, and what that did was it helped achieve a vacuum. If you'll think about it for a moment, when you have air going through a pipe, you have the same amount of air entering that pipe as you do exiting it. Okay? Well, by putting these obstructions in here, you've created a narrowing right here. So if the air is coming through here and it has to be the same amount exiting, you get a much faster airflow right here. And that will help create a vacuum up of this pipe, pulling the fuel from the bottom of this bowl. Now, while we're talking about that, let me tell you how we're going to regulate the amount of fuel in this bowl. If you think for a second, on our engine we have a gravity-fed fuel tank, meaning that it's above our fuel bowl with a fuel line here. And if we didn't have some way to regulate this, this would just keep overflowing. The way they've overcome that problem is with a float system similar to your toilet. Right here is a needle valve and a seat, if you will. The fuel comes in through this little hole right here, and when this needle valve is all the way up, the fuel can't come into it. But as this fuel is depleted, this floats on top of the fuel, and as it goes down, it exposes this needle valve right here, and fuel will come in. And as the fuel enters this bowl, this float will float to the top, again closing off this needle valve. So we keep getting this action. Fuel comes in, floats up, closes off the valve. All right, on to our next model. We have to somehow control the amount of air-fuel mixture that ultimately ends up in our cylinder. And the way we do that is with a plate called a throttle. And it'll look similar to this. Okay? And that goes between the carburetor and the engine. And when it's in this position right here, that's called WOT, or wide open throttle. And that's letting in the maximum amount of air-fuel mixture into the cylinder. But as you start, and the engine is going as fast as it can, and as you start to bring the throttle into a vertical position, you're slowing down the engine and starting to starve it of air fuel. And if we were to leave it straight up and down, okay, that engine would stall. So we had to create a secondary circuit, if you will, allowing fuel to somehow bypass this plate and still feed this area, allowing fuel into our engine. And we do that with, again, this circuit right here. So if you were to take that carburetor cleaner and you've all done it, and you go into a port on your carburetor and it squirts out in an unknown area, it's these secondary circuits that is happening. And oftentimes they'll get clogged, but we'll get into that when we get into the cleaning of these carburetors. But again, wide open throttle, maximum amount of air fuel. As we start to slow it down, we're going to have a way of getting fuel past this plate, and it's with this low speed circuit. Which brings up another point. We're going to have two adjusting screws, okay? One for the high speed, which would be this main jet or this main pickup tube, and we're going to have another one right here, which is controlling our idle speed, okay? Now, when we go from high speed to slowing the engine down and we want to go back to making this engine rev, there's going to be a delay from this pickup tube to catch up with the amount of fuel that we need. And that's where these extra holes come in, extra transitional holes come in. And all that means is it's allowing more fuel coming out of these little ports until this can catch up. Now, when you first start your engine and the engine is cold, you're going to have a plate similar to your throttle in the front of your carburetor, and that's called a choke plate. What we're going to do is we're going to close off or choke the carburetor, meaning we're not going to allow as much air into the carburetor as we are fuel. Okay, so we're going to have a rich fuel to air ratio, allowing a better explosion, if you will, inside your cylinder. That's only when we're starting it. Once the engine's running, we're going to open our choke to allow the maximum flow of air fuel through this carburetor. I hope that cleared up some understanding of the way a carburetor works. I'll catch you on the next video.